Hi, my name is Ruth, and today I'm demonstrate about microservices architecture used by Dropbox and its scalability and performance. So my student number is MS22038050, and so Dropbox is usually basically user able to upload their files and download files in secure manner, and they are cloud storage, and they used microservices for the Dropbox. And Dropbox earlier stage they used monolithic architecture, and with customer growth and their services growth, they moved with the microservices architecture. So this microservices architecture is highly maintainable and testable and independently deployable and also loosely coupled. So this means that each service can develop do the development by separate team can do the separate team, and also the deployments also do the separately, not like when one monolithic case can should deploy its complete project, but in this architecture only need to do the separate which service that need to be deployable. So also that to make sense about loosely coupled, so that enable the teams to work independently without being impacted by changes to others, and is highly maintainable with rapid frequent development and deployment. And so the key success about scalability is when come to the business end, scalability enables the company to expand their generated revenue without being limited to its structure and lack of resources. But when come to the technical end, microservices-based program usually includes a number of services and components. And as a result, if they need to scale microservices-based program, they must either expand entire application at once or identify the components and the services that need to be scaled up. And when it comes to the scalability, there is two type of scaling. And first one is vertical scaling, and the second one is horizontal scaling. So what happens in vertical scaling is increase the size of instance. That means we have to increase RAM size and CPU size and maybe the storage as well. But what happens in horizontal scaling is we have to add more instance with the same size of instance. So basically, it size increase the size of in vertical scaling, and horizontal is add more instances in same size. And when it comes to the horizontal scalability, it usually applies to the microservices as well. So microservices usually goes with the that mean horizontal scaling. So it make it easy to scale up services with looking at which need to be scale up. That means if they are need to if they are if some service have more traffic in certain period, that can be scale up by looking at their performance and their traffic, and this is actually scaling done is automatically. So this automated scalability is supported by container management technologies such as Kubernetes. And when it comes to the performance key success, in the business end, more sales generally rise from faster service to the end consumer. Better software services have the direct impact on company value, and that means so when user use their services in Dropbox, uploading the use files and downloading files from the storage, that thing should be more better performance in their mobile as well, because it's direct impact to the system. And since Dropbox can identify which small application is simply not performing, and that microservices allow to them to see which microservices of their system is not working, because they are break down to their services. So they can directly identify which service is not working, is not well, and they can apply the changes and simply scale up or optimize. And this is the architecture of their system, and this is how uh, desktop application and mobiles how talk with their servers. This is the SSL and TLS layer, and this is how each service talk to each other. And they have preview storage servers and block storage servers and metadata databases and metadata servers as well. This includes notification service like that. And this is about my finding about scaling in Dropbox. And earlier stage, Dropbox was known as Magic Pocket, and they provided the storage services to only 1,000 users, and they have used AWS services for deployment like AWS S3. And when the scale is required, they build their own dedicated storage infrastructure. And 2.5 years later, they announced that they now storing the serving over 90% of their user data to custom built infrastructure. So also they did uh, two regional location, and they more uh, provided regional locations in worldwide. And their goal was 90% of their data from in-house infrastructure on October 2050, and also they achieved that significant technology in without lost any base data. So making their own infrastructure is basically they have their own power to do whatever the need when users with the user growth, so they can actually uh, upgrade their data centers, and they can introduce new data centers as well. So basically their own having their own infrastructure mean they not depend on any other, so that's a good thing for their. And And when come to the performance end, that they have metadata servers and metadata databases and preview servers. So what happen in metadata servers? They 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 have certain basic information about user data called metadata, and it's kept its own discrete data storage service and acts an index for the data of user accounts. So that means they actually no need to uh, this is actually you don't need to go and take the every time taking a complete information from the database. They actually keeping these metadata can faster performance can uh, perform here. And for preview storage service and preview storage service, like it actually useful when most of time users actually preview their images and files and most of time. So having separate services and services is usually good because it can independently scale up or scale down whenever the need, whenever the about the users using about user traffic. And actually, I noticed that there are other quality attributes as well. It's availability. And breaking into several microservices will not only help to the scalability and performance, so it helps as high availability of the system. So that means even if one service fails, that for example, even if the notification service is completely down, even other services are still supplied the service. That's not much impact to the users because 80% of the system is still up and running. And they have made huge trade-offs, and they have partnership with Zoom as well. So we all know Zoom is meetings, collaborating meeting and video recording. So they now can present Dropbox files in Zoom meeting, message about Dropbox file from Zoom, automatically save a copy of record Zoom meetings in transfer to Dropbox. Also, Slack as a cooperation messenger service that help to keep share files and things. So these files can now individually uh, directly from Dropbox easily share in the workspace. And this is advantage is no need to switch between platforms in Dropbox and the Slack. It can actually integrate it to the Slack. And they have also partnership with Adobe Creative Cloud and also the Trello. So my judgment and recommendation for the system is overall Dropbox system is architecture and its scalability and performance are a step ahead from other systems. not limited to selected quality attributes. It has many other better quality attributes like availability and reliability as well. Considering finding this system can recommend to users, and this architecture also can recommend and use their needs. The user can use their needs and technical, and we can also refer their the architecture. And however, there are a few suggestions for this system when compared to the other systems that make this system more successful in every aspect. Yeah, so my suggestions are Dropbox is better when coming to the file organization, but it really poor for the file search. Like Google Drive provides massive options to research search files. So Google Drive did better on their security for files. So both Google and Dropbox, that may basically mean both Google and Dropbox encrypt data before storing in the cloud. And once they produce a key that is used to decrypt it when the user needs to access it. And Google goes a step further by encrypting the key with a second rotating master key. This means that anyone who might steal data from Google's servers would require two keys to view user data rather than just one, as with Dropbox. So this suggestion will make this system more successful. And this is the comparison with the competitor system. So I do this actually researching some more research, reading research papers and things, and these are the numbers that I able to find about these Dropbox, Google Drive, and OneDrive. So basically, download speed is in Dropbox is 1,000 seconds, and the Google Drive also 1,000 seconds, and the OneDrive is the amount that take more time to spend download some file. And when come to the upload speed, it actually Google Drive is most uh, time take to the uploads one file, and then Dropbox, and the last one is OneDrive. And synchronization is taking first place in Dropbox. And synchronization means actually the two places that sync with each other. That I mean our local file storage and the Dropbox cloud storage, that takes how much time to synchronize in these days. So Dropbox is the 13 seconds take to do that. So in the completion mean I took the all the store the took the file size is 1 GB. So I spent time in seconds in every numbers in here. And so the completion time is calculated the time difference between first packet and the last packet in any of those storage. So it also uh, is the fastest one in Dropbox, and Google Drive is in the second one, and the third one is OneDrive. So considering to these two storage, this is a huge win for the Dropbox. And the protocol overhead in here is that criteria for calculating the protocol overhead is calculate the ratio of the total storage and control traffic to benchmark. So Dropbox is the win as the 0.2 because it's also the huge one, and comparing to the Google Drive in the OneDrive. So that's uh, that's the comparison for these computer systems, and that's all for this uh, architecture and the quality attributes of this presentation. And thank you.